base 10 fraction is a fraction where the bottom number, which is called the denominator, is a power of 10. That means the bottom number can be 10, 100, 1000, or even more. The top number, which is called the numerator, can be any number. It could be 3, 5, 7, or any other number. The cool thing about base 10 fractions is that we just put the numerator in the right place according to the denominator. If the denominator is 10, the numerator goes in the tenths place. If the denominator is 100, the numerator goes in the hundredths place. If the denominator is 1000, the numerator goes in the thousandths place. But there is one important thing you need to know. What happens when the numerator has more than one digit? You will see that in just a minute. Let's start small. 3 over 10. To convert this, we'll use place value boxes, so the numerator is easy to place. One box for the ones place. One box for the tenths place. Or you can think of it as, we need boxes according to the number we have on the bottom. Also, it's good to know that we have to move the decimal point from right to left according to the zeros we have on the bottom. This separates the whole from the fraction part. Now we have our boxes. The 3 goes in the tenths box. If there are no whole ones, we put a 0 in the ones box as a placeholder. In fact, we don't even really need the ones box for numbers less than 1, but we keep it anyway, just to make things less confusing. Next, let's try 4 over 10. The bottom number is still 10, so we are still using the tenths box. The 4 goes in the tenths box, because it represents 4 tenths. Now, what about the ones place? We don't have any whole ones yet, so we put a 0 in the ones box. That 0 is just a helper. It reminds us that there are no whole numbers here, only tenths. So even though we don't really need the ones box, it helps us see the difference between ones and tenths. And just like that, 4 over 10 equals 0.4. So, what about 10 over 10? Remember, the bottom number 10 means the whole is cut into 10 equal pieces. The top number 10 means we took all of them. You now have one full thing. Everything comes together to make one whole. That's why 10 over 10 equals 1. See? Tenths are easy. Now let's move to hundredths. Let's start with 1 over 100. The bottom number is 100, so the whole is divided into 100 equal parts. That means we need 2 decimal places because of the zeros we have on the bottom. Tenths place and hundredths place. We only really care about these 2 places, but including the ones place box is very helpful. It helps us to see clearly. Since we are taking just one part out of 100, the 1 goes in the hundredths box. We don't have any whole ones, and we don't have any tenths yet, so we put zeros in the ones and tenths places as placeholders. That gives us 1 over 100 equals 0.01. Let's try 7 over 100. The bottom number is still 100, so we are still working with hundredths. We need ones place, tenths place, hundredths place. We are taking 7 parts out of 100, so the 7 goes in the hundredths box. There are no whole ones and no tenths yet, so we put zeros in those places to hold their spots. And just like that, 7 over 100 equals 0.07. Now, let's look at 15 over 100. The bottom number is 100, so we are still working with hundredths. This time, the top number is 15, which means we are taking 15 hundredths. Here's a helpful way to see it. We can break the numerator into parts. 15 is 10 plus 5. The 10 out of 100 is the same as 1/10. The 5 out of 100 is the same as 5/100ths. Now we can place these numbers into our place value boxes. Ones place gets 0 as a placeholder because we don't have any whole ones yet. Tenths place gets 1 from the 10 out of 100. Hundredths place gets 5 from the remaining 5 out of 100. So when we write the decimal, 15 over 100 becomes 0.15. Here is something interesting. If the numerator is bigger, like 120 over 100, let's break it into parts. 100 plus 20. 100 out of 100 is 1 whole. 20 out of 100 is 20 hundredths, which is the same as 2/10ths. Now we can place these numbers into the place value boxes. Ones place gets 1, which comes from 1 whole. Tenths place gets 2 from the 20 hundredths, 2/10ths. Hundredths place gets 0 because there is nothing left for that spot, but we still write it so the decimal makes sense. So when we write the decimal, 120 over 100 becomes 1.20. Next, let's look at 3 over 1,000. This time we only have one digit on top, so we can't really break it into parts. That means we use the old trick. We need 4 boxes. Ones place, tenths place, hundredths place, thousandths place. We are taking 3 tiny parts out of 1,000, so the 3 goes in the thousandths place. We don't have any whole ones, no tenths, and no hundredths yet. So we put zeros in those places to hold their spots. And the number becomes 0.003. Now let's look at 145 over 1,000. The bottom number is 1,000, so the whole is divided into 1,000 equal parts. The top number is 145, which means we are taking 145 thousandths. Here's a helpful way to see it. We can break the numerator into parts. 145 is 100 plus 40 plus 5. 100 out of 1,000 is 1/10. 40 out of 1,000 is 4 hundredths. 5 out of 1,000 is 5 thousandths. Ones place gets 0 because we don't have a whole one. Tenths place gets 1 from the 100 out of 1,000 1/10. Hundredths place gets 4 from the 40 out of 1,000 400ths. Thousandths place gets 5 from the 5 out of 1,000 5,000ths. Decimals can always be turned back into fractions by looking at the smallest place value. Here's how it works. Look at the last digit in the decimal. That tells you the smallest part. Use that place value as the denominator of your fraction. The numbers before it become the numerator. For example, 0.145. The last digit is 5, which is in the thousandths place. That means the denominator of the fraction is 1,000. The digits 145 become the numerator. So, 0.145 equals 145 over 1,000. Another example. 0.15. The last digit is 5, which is in the hundredths place. That means the denominator is 100. The digits 15 become the numerator. So, 0.15 equals 15 over 100. Quick recap. Base 10 fractions have denominators of 10, 100, 1,000, and so on. Decimals can always be turned back into fractions by looking at the smallest place value. Once you practice a few, it all clicks because our number system is based on powers of 10. And that's it!